Hi, I'm Dan. I've taught high school science for 29 years, and today I'd like to try and make sense of some of these COVID death rate numbers we keep seeing on social media. Death rate doesn't mean what it seems like it should mean, or at least not what I thought it should mean when I first heard the term. Death rate actually is defined as the ratio of deaths to the population of a particular area. So when they say death rate, they don't mean the number of people who died from the disease, COVID in this case, of the people who had the disease. They mean the number of people who died of, in this case, COVID, out of all the people who live in the United States or whatever country we're talking about. I'm going to call it per capita death rate because it makes sense to me that way. I don't know if it, hopefully it'll make sense to you. Per capita death rate is not an official term. Per capita death rate for a disease depends on many factors, but the important thing is that it is highly influenced by the number of cases. Therefore, it cannot be a measure of how dangerous a disease is because low number of cases, low death rate, high number of cases, high death rate. It does not tell you how likely you are to die from the disease. This is very important. It cannot tell you how likely you are to die from the disease. Now, there's another term referred to as case death rate. Case death rate actually means what I used to think death rate meant. Case death rate is how many of the people who contract the disease, COVID in this case, die from the disease. Case death rate is an actual term. It's also called case fatality rate and case mortality rate. It also depends on several factors, but it is not heavily dependent on the number of cases. By the way, it's not heavily dependent on the number of cases unless there are so many cases that it is negatively impacting the healthcare system. Because it's not heavily dependent on the number of cases, it's a better measure of how dangerous the disease is. And what does it tell you? It tells you how likely you are to die from a disease in your country, because different countries have different case death rates. If you catch the disease. If you don't catch the disease, you can't die from it. That's just that simple. So to give you an idea of the two, excuse me, Ebola in the Democratic Republic of Congo in 2018. There were 54 cases and 33 of those 54 resulted in deaths. The population of the Democratic Republic of Congo was 84 million, which gives a per capita death rate of 0.000039%, virtually nothing actually, but a case death rate of 61%, quite high. And by the way, that is a little overly high. It illustrates how it can vary from case death rate can vary from country to country, because the overall case death rate for Ebola for all outbreaks is around 50%. But notice the huge difference between the per capita death rate and the case death rate. I would point out that if a disease is fairly contagious, a big difference between those two numbers may tell us how well the disease is being controlled. But what about COVID-19? How does all this apply to COVID-19? Well, as of August 9th, these numbers from Johns Hopkins University, there were almost 5 million cases in the United States of COVID-19, 162,000 deaths. All out of a population of 331 million people. That works out to a per capita death rate, or just death rate, of 0.049%. And this is the number I see frequently on social media. But remember, this number does not tell you how likely you are to die from it. It would only tell you your probability of dying if it were random, and it's not random. You have to catch it first. The case death rate works out to be 3.2% from these numbers. But, you know, how accurate are those numbers? We all heard the horror stories about overcounts and undercounts and inflating numbers, and how accurate are they? Well, there was a recent MIT study suggesting that the infections are actually 12 times higher than reported, and the deaths are 1.5 times or half again higher than previously reported. So if we modify the Johns Hopkins numbers based on this MIT study, we come up with almost 60 million cases, huge jump in cases, 243,000 deaths, a little bit of a jump in deaths, and still the same population. That works out to give us a per capita death rate of 0.074%, or about 50% higher, which figures because we have 50% more deaths, but still very, very low. And a case death rate of 0.41%, which is much lower than the 3.2% using the Johns Hopkins numbers straight out. So, 0.41% case death rate doesn't seem all so terribly bad. So let's put some perspective on it. Herd immunity is necessary to protect the population from a disease. So hopefully we will be able to reach herd immunity for COVID and more or less be protected. In other words, somebody will get it here and there, but there won't be enough contagious people. I don't mean contagious, susceptible people to be able to pass the disease easily. So hopefully, if we can reach herd immunity in COVID-19, it's going to be somewhere in the 80% of the population, probably. So assuming no vaccine is developed, assuming that the only way someone can become immune is to actually have the disease, out of those 331 million people, 80% maybe would have to get the disease. I can tell you, I say maybe. It may be higher than 80%, but it's not likely to be lower. So 80% of the population is 265 million. And if our 0.41% die of those 265 million, we're left with 1,100,000 deaths from COVID. That seems like a big number, so putting it in perspective, the number of people who died in the United States in 2018 of all causes combined was 2,200,000. So this means worst case scenario, COVID is capable of increasing the 2020 death rate in the United States by 50%. So what are our conclusions? What conclusions can we draw from this? And you know what? You can draw your own conclusions. I'm not here to tell you how to think. I'm here to explain how the numbers work. So have a nice day. I hope this was helpful. If it was helpful, you can feel free to share. And well, again, have a nice day.